So the mixed hardware, firmware, software products tend to have multiple teams of engineers by engineering discipline, and each of those disciplines is typically managing their project the way that works best for them. So you have a mixture of management methods going on, a mixture of life cycles or development processes. The hardware programs typically look pretty waterfall, or at least from a software perspective, we'd describe them as waterfall, where all of the features are being developed at once in one huge bunch, and they're all going through some sort of design and then building a lab prototype and doing a lot of testing, and then doing a production prototype and doing a lot of testing, and things get found fairly late, cycle back to the beginning. At some point, they start integrating that with firmware. When it's only a hardware project, they usually set up the testing so it looks kind of like this. You've got these long test suites with a whole lot of different kinds of testing piled into them. You've got reliability. I've seen reliability testing and functional testing in the same test suite. And the reason this is being done is to minimize the number of prototype units that's needed. Those prototype units can be pretty expensive. So the group is doing something that's actually fairly sensible, is putting as many tests as possible onto this particular prototype unit, and that affects the way they organize the tests. So you get these really long test suites. In the days when firmware was being done, with the waterfall life cycle, they would integrate into this with some difficulty, but it kind of made sense because they were also doing all their features at the same time. But when they started switching to Agile, we see difficulties arising because you've got these long test suites and this assumption that the unit item under test is staying the same throughout the test suite, but you have these firmware teams who are wanting to give you new deliveries every week, every 2 weeks, every 3 weeks, they're choo. And then the software teams start also coming into play. So now it's a smart device and it has connections to the cloud, and the software teams are delivering things, and they're also dropping them in rapidly and not always on the same schedule as the firmware teams. To make this even more complicated, I find that very often the teams are not using the same type of language to describe what they're doing. The testers have names they've used for the test historically. The firmware teams have a bunch of epic and user story names, and a lot of times they're at a pretty granular level. So the hardware and test people look at them and they're not, frankly, really sure what the firmware teams are talking about, and vice versa. So we end up with a situation where it's pretty easy for the project to get out of control, in the sense that people are not sure what is actually testable. They've each done their planning according to the way they've been told they should be doing their planning. And the end result is the firmware team will drop something in and expect to get test results back in a week or so, and it's 5 weeks later. And they may have even thought there weren't any defects and happily gone on to do new features, but no, there were defects. They just weren't up for test, or they didn't get reported until the end of the suite. On the other side of the coin, the test group is starting a suite, and I've had this happen to in my test teams. They start a suite and it fails miserably. Like, the feature doesn't even run, and you go ask why, and the firmware team scratching their head and saying, why are you trying to test that now? It's really clear in our delivery plan that that's not coming till the next sprint. But it wasn't clear to the test team. So a lot of confusion. And yet it doesn't make sense to say everybody needs to manage completely differently. There's pressure sometimes on the hardware teams. Why can't you do Agile like the software people and do everything in these little 2-week sprints? And the thing that's getting in the way of that is the cost of change. On a software project, you can change the software if it turns out that you didn't understand something about the environment, and when you integrated it, it didn't work, or it worked great, but the user didn't like it. You can change it. You can change it in a week. A lot of times you can change it in a day, sometimes in a couple of hours. But if a plastic part cracks during testing, you're not going to change that in a week. You're going to have to think about, do I get new plastic or do I make this part a different shape? If it's a different shape, I have to do new molds. Then I have to remold it. Then I have to install it. Then I have to run I mean, it's not going to be a couple of days. It's going to be weeks and weeks. So you've got a lot higher cost of change. And so the way that hardware teams, and in particular mechanical engineering teams, go about doing their investigations, their design, and their testing is working with this high cost of change. So if you tell them to do something radically different, they run into issues. So it sounds like you're just kind of stuck with all this confusion. But I have found that you aren't, that you can apply Agile principles to come up with a way to do integration planning that makes it a lot easier for everybody. And that's what I'm going to show you today is the slice-based integration planning. So this is based on two principles out of Agile software development. One of them is small batches. And not everyone realizes that this is one of the fundamental things that's making Agile work, is that instead of doing all of our features in one huge group, which we did in the waterfall days, we are splitting the features into small groups. And we're delivering one batch at a time or a little group of batches. And then each of those batches is something that works, that delivers value. In the ideal internet world, you can actually release them. Firmware, not so much. People don't want to buy a product that doesn't have all its features yet. But the working software is still critical. And the people who wrote the Agile Manifesto realized this. One of the principles in their list is working software is the primary measure of progress. And what they're talking about there is the small batches and being able to finish a batch and know that it works and the value of that. So you've got these batches. And the other thing we're doing with the batches is we're optimizing the flow of those through our development process. Since the batches have value, we want to get the highest throughput, the most number done in a given amount of time with a given amount of people. And we're looking at our development process where they're walking through in design, testing, and then maybe they have to go to a different group for integration testing. And so there's management methods that have been worked out to make this work. 3 of the tools that you see in all of the Agile methods, they're not used the same way in every Agile method, but you see these same 3 tools. One is batch size, getting a good batch size for your process. And how big should your user stories be? How long should your sprints be? It's different in different contexts. Another tool, a really powerful one, is cadence, having a regular schedule. So your sprints are the same length, which means your sprint planning meeting is on the same day of the week. Every couple of weeks, everybody can plan around that and know that if they want different user stories in this sprint, they need to come in and talk about it right before the sprint planning meeting. So it provides an anchor, a foundation, some structure for the schedule. And the third one is work in process control or WIP control. And this is the principle of finishing stuff before you start more stuff, which is not all that intuitive. There are a lot of people who will look at an overloaded group and say, you're not making progress, therefore we need to start more things so that management will see we're really working on their stuff. It is, however, mathematically provable that that is not the thing to do, that you will get more done if you work on a few things and get them finished and then work on some more stuff. And the math that explains that proves that, is queuing theory. Queuing theory is a body of math that describes how work flows through a system. And there's equations that you can plug in different values for different types of systems and see what happens. This was invented over 100 years ago. Is originally developed for designing telephone switching systems when telephones were brand new and trying to figure out how many operators and how much equipment do I need for a load of phone calls, which are going to come in at different times, somewhat randomly, and be different lengths. So very powerful body of math that's been used in telecom extensively since, and in a lot of other fields. Sometimes the people using it did not realize right away that queuing theory explained what they're doing. And in Agile software development, you saw the development of Agile. And then about 5 to 7 years after that, after the codification in 2000, you started seeing people writing, wow, queuing theory actually explains what's going on here. And that gives me some more tools to think about what should my management processes be, what would be the most effective. And for our purpose here with our mixed hardware firmware systems, the queuing theory gives us the ability to apply those Agile tools in a system which isn't classical Agile software. It's got a high cost of change in part of the system, a low cost of change in another part, and in multiple development streams going on at the same time. So we can use the principles informed by queuing theory to look at what's going on. When you look at the system with all these short fast things coming in, and then the long, slow suites and development going on, we want one batch running through here. And we have to look at the different sizes, like, do we want to make the firmware and software batches longer? Do we want to make their sprints longer? Well, no, this is not on the table because that would slow those teams down. It doesn't make sense. Likewise, looking at the hardware teams and saying, oh, hardware teams, you need to work on 2-week sprints. This doesn't work either. There's a number of reasons why it doesn't work, but it gets very, very awkward. So what we can affect, though, is the test suites. We can look at these test suites and see if we can make them smaller, treat them as batches, and think about what would happen if we make them smaller. Queuing theory tells us making them smaller is good, but it also tells us that too small doesn't work. And each batch has some overhead. The act of being a batch, having a sprint means you have a sprint planning meeting at the end, a sprint demo, and you get some overhead for being a sprint. You also get overhead for being a test suite. So we have some overhead and we incur that overhead for every single batch. So if we make really small batches, we have a whole lot of them, that adds up to a lot of overhead. That overhead can end up overwhelming the value or the benefit of having the smaller batches. And queuing theory has math that shows you how to think about this. I'm not going to include that today, but if you read the paper that I wrote, it's got references that go to a blog post, which gives you pictures of the math and the equations for people who really like math, which I thought was pretty fun. But once you understood it, then you didn't actually need to apply the math most of the time, which is kind of good. So what you end up learning is you need to look at the overhead, and the overhead is specific to your project. So your organization will have overhead. Mine, when I was doing LaserJet printer testing, involved putting, you had all these printers that you had to set up. So at the beginning of every test suite, we had to zero out all the firmware, install new firmware. We're bringing in paper, we had controllers that had to be put back to a clean system. A lot of times in software groups, this is all automated, but when you're working with physical object, there will usually be some pieces that you can't automate. Somebody's actually picking stuff up or going to an object and making it do things. So there's setup time, there's teardown time. You may need to have more prototype units than you did with the big, huge omnibus test suites. And so that's an additional cost. So you think about all this and think, what would be a reasonable test suite size? Shorter than what I have, but not so short as to insanely increase our costs and effort. So you pick that and use that as a guess to create a cadence in your system. And this cadence provides structure that's going to help all of the planning. It gives you a place to put your feet and be able to build the planning on top of it. So we choose a cadence where we have a time box. We split the whole calendar to regular time boxes, and we have time box that is big enough to fit our average test suite that we thought we could split it down to a smaller size. It will fit into this time box. So usually I tell people when we're teaching this is try the firmware sprint lengths first. And if that seems reasonable for your test suites, go with that, because then you're automatically able to line up your time boxes with the firmware deliveries. If it's too small, then do a multiple. So if your firmware is running on 2-week sprints and that's just nuts for you, then do 4-week time boxes. So you split your calendar into time boxes, and then we're going to connect the work of all of the teams, the software deliveries, the firmware deliveries, the test and the testing, by defining slices of user visible behavior. So we're creating an artifact to fit into the time boxes is a list of which features we are going to work on in each of those time boxes. So this is starting to look like Agile, where we're talking about features that we would hope to have delivered to test, and maybe they'll actually even be finished in this time box. This works best if the slices have names and or descriptions that are in terms of user visible behavior, because one of the big issues in these types of projects is everybody's using their own language and they literally don't understand each other, and a lot of times don't want to admit it. So user visible behavior is both pulling the project along in terms of features, and it's allowing everyone to communicate, because everybody knows and can talk about the behavior, including the program managers and marketing people, and people who aren't even involved in the technical building can talk about this sensibly. So some sample slices that you might see: printing a test page in response to a button press, recovering from running out of paper, a lot of end-to-end user behavior. So these look a lot like user scenario tests. We often start finding them by looking for user scenario tests. It's not just end users, it's also the manufacturing line, because part of creating a physical product is creating a manufacturing process. And that process includes tests that are run during manufacturing. So those are a deliverable. And so we have slices around those deliverables. We can successfully run the manufacturing test that proves this printer is aligning its cartridges correctly and can go on, down the line. So these are a lot bigger than user stories. They're not, back for a minute, they're not user stories. They're not, you don't need to use the same specific language that is used to create user stories. These are a lot larger. They're more the size of epics. Some places I found they're bigger than epics. So they're very high level, and we just want a sentence or two that's describing what they are in terms people can understand, that will kind of gather together the development and the tests for them. I call them slices because the most helpful ones seem to be the ones that slice through the layers of the architecture. And again, this is a concept out of software development as well, is a slice where the printer is reminding the user to purchase more ink, is got physical stuff going on inside the printer to detect the status or the amount of ink used and the status of the cartridge. And then that's communicating with the firmware, which is communicating with the software driver to pop up a message on your screen suggesting you should buy some more ink. And then that might be going out to giving you a link out to a cloud site that would allow you to buy the ink, order ink right then and there. And so you've got a bunch of different parts that are included. Some of the slices don't go through every single layer of the architecture, and particularly when you're first starting integration. Typically, when you first start integration, there's been a whole lot of work already. This is not the beginning of the project. There's been a lot of hardware development to get to the point, for instance, where you can walk up to a printer, press a button, and get a test page. There's a huge amount of work that goes into that. But that is a valid slice that ties together the firmware and the hardware, so that you can say that's a place we can test this, we can show that it's working, we can move on to other slices. So then we can build slices that pull in another layer. We can print a page from a PC, so now we can use Microsoft Word and print stuff, or you can print a page from a mobile app, and so on and so forth. So if you're starting this method and you've got your traditional test suites and your traditional delivery schedules, how do you get started? easiest way to get started is to start looking in the test cases and test suites for things that look like slices and making lists of them. If the names in the test suites and cases are really arcane or highly technical, sometimes I found that it helped to go look at the firmware delivery schedule and look at, especially if they were doing epics or themes for their sprints, because a theme for a sprint is about the right size, much more so than user stories. So we would be looking at those. You would think that looking at the requirement specification would give you slices, but actually, in my experience, it doesn't. The requirement specification is not put together in the order in which things are going to be delivered. And the test suites and the delivery schedules have already spent a bunch of time thinking about what order do we need to build this thing in. We can't just build stuff in any order we want, not with a physical product. You need to do it. You need to have buttons before you can have tests around the buttons, and it's not nearly as flexible as software. So don't usually use the requirement specification for a source of slices. And another issue with it is that the specification often doesn't include all the features. You'll find a bunch of features that are actually documented in test cases. Anybody have that, where there's things that are only in the test cases and not in any of the requirements? Yep. But to make this work, this is not just a test group process. This is something for the whole program. So this is the technical leads sitting down together. This is software, firmware, hardware, test group leads all sitting down together and trading what they have or what they were planning and trying to make it all fit together and make sure they understand all the way through. So you take this schedule with the time boxes, and this is why the time boxes are important, is because it gives you a place to start. You've got the time boxes, and they have, and you're splitting your calendar into time boxes and asking, if I put, for the sake of a place to start, well, we've guessed at a bunch of slices, we put a bunch of slices into time boxes, and then we start asking the tough questions. Can we line up the tests with this? Can we line up the delivery schedule? What is it going to take? What's going to be different than the way that we have the plan today? This takes a while the first time you do it. After you've done a project this way, or even a couple of months this way, it starts to get a lot easier because people are thinking about the slices from the beginning. But the first time it takes a fair amount of discussion. So you're going through looking at things like, here's a test suite, it's running over, the current schedule calls for it to be started in the middle of time box 3 and go through time box 4 and lap over into time box 5. And this is just messy and not helpful. So what if we started it halfway through time box 3? We look at the behavior and see that that means moving slice 5 from time box 4 back to time box 3. So you've got a discussion with the firmware team on whether they can move that forward. So this collaboration is talking about, can we move this forward? If we move this out, and juggling things around until you get something that lines up. So you take another suite, all you might need to do is split it so that you can start things at the beginning of a time box, and you start to build this idea that people are going to deliver their stuff at the beginning of the time box, and the testing is going to start at the beginning of the time box. And if it doesn't start then it's going to be the next time box. It's not going to be trying not to do things in the middle, although when people first start this, they often do have a point in the middle of the time box where they have a new delivery. Some things you just need to move over a little bit, like this suite D1 and D2, just scooch them over a little and it's fine. And nobody has to really change what they're doing. And another example of splitting things across two time boxes. And in this case, if you look at this, whoops, I'm going to go backwards here. Suite B1, we're going to move it earlier, but we're not going to take its entire slice with it. So we end up having a newly defined slice. I find this happens a lot. This is why it's not really a good idea to name the slices with these sequential numbers, because you have 1, 2, 3, 4, 5, and you keep having slice 1.5 and slice 2.5. So just don't give them numbers. It doesn't help a lot. But you work through this. And the artifact people use for working through it usually is a plan that looks like this. So you do a simple plan based on the calendar that you can do in a spreadsheet or a table or any tool you're currently using that does spreadsheets and tables. And across the top, you put your time boxes, and then you put your slice definitions, because that's what's going to tie the whole thing together. And then you start listing under this. These are the tests we have planned. Are those matching the slice definitions? And then all the stuff in blue is the items under test. So the hardware and the firmware, and you can list the drops, and the firmware people can look at that and compare. This is my drop. There's the system test. There's the slice definition. Is that actually making sense for me? Is this what I thought was going to get delivered? I've found that the hardware people tend to describe their prototypes as being static for many weeks. We're working on prototype 1, and it's going to be 6 weeks on prototype testing on prototype 1. But actually, they have a tendency to run in with hardware change in the middle of that. Not a lot, but the occasional. So I found it's helpful to add a row to keep track of the hardware changes that are showing up. And just let that go. So this is managed a lot like an Agile software roadmap. So if you read about Agile software roadmaps and like Joanna Rothman's work or SAFe or whatever, a lot of the techniques that you use there can be used to manage this. It is not a complete plan. I've never seen anybody be able to do a complete plan for their entire integration sequence on day 1 and have it not change. Usually they have chunks that they don't even know what it's going to look like. So it's fine to have some of the stuff that's later out in time or further out in time be TBD and just say you don't know. It's fine to say you don't know, because we're going to manage this plan in a repetitive, consistent way, just like we do our Agile software projects. Cross-functional team reviewing this at least once every time box, and it's better if you do it weekly, at least at the beginning. But this is the cross-functional technical leads. It's not a status meeting. It works best if you don't try to combine it with an existing status meeting, because this is a meeting where you don't want the managers there, other than maybe the program manager, if that's the person coordinating all of this, which it often is. But you're not reporting on the success of the project or the defect find rate or the burn down or anything. You're having technical people are getting together to coordinate their work across teams in the way that they need to do it. So it works pretty well to treat it like a stand-up meeting, although they are kind of long for actually standing up. It's not unusual for these to be half an hour, or at the beginning, an hour when people are first learning the technique. So there's 3 questions to ask. The first, and those questions are asked of each one of the technical leads, which includes the testing lead. First one is, for this time box, has your planned delivery changed? Anything changed? Anything that had to be left out, that got added, dates, anything? And so that's the software deliveries and the planned testing. So each person answering that. The second question that is asked of the person, is anything blocking your plan for the next time box? And this is where we find out if people think they can't get something done, particularly if somebody else might be able to help. We can't get this done because we've got a blocking defect. That's something Test Lab would bring up. Another group is saying they can't get something done because someone's run off with a prototype part that it got borrowed, and where did it end up? Oh yeah, this we're not the only ones that have that happen, huh? Yeah, that kind of question may be short enough to actually answer in the meeting. Most of them you need to say who's going to work on this together after the meeting. But this is the point to surface things that are going to be blocking progress in the next time box. And then the last question for the technical lead is there anything else the other technical leads need to know? Anything you want to tell us that we should know? So people work with this, and after some time they get pretty disciplined at doing the meeting and understanding what questions do they need to ask, what types of things should be brought up. And because it's all focused around the time boxes and the slice definitions, the communication is pretty clear. The firmware team still has their detailed delivery plan. The test group still has their detailed plan. This is like the meta plan, or the one ring to bind them all. It's bringing everything together and helping them coordinate across the teams. So in short, the slice-based integration planning consists of finding what you think is the smallest practical test suite size and using that to determine a cadence, and splitting your calendar up into time boxes according to this cadence. Then splitting up your test suites so you think they're going to fit into the time boxes. The firmware already and software generally already fit into the time boxes. And then you define slices that for each time box, there's going to be your basis for coordinating the tests, the firmware deliveries, the software deliveries. So people are starting to work on groups of features, very high level groups of features, and using this integration plan as a visual plan. You want it somewhere where everybody can look at it every day. They have a question, they're wondering what might happen next, they can see it. And you want to manage the plan on a regular, frequent basis to make sure that you're using it as a tool to keep things coordinated and that it's staying up to date. So you might ask, is this Agile? Is this actually Agile? Frankly, I don't care whether you call it Agile or not. There's way too many arguments about what's Agile and what's not. These slices have a lot of resemblance to Agile software on a much bigger level. They are chunks of the entire system. So it's not just the software. They are being defined by cross-functional teams. They are centered around features and behavior. And you can use a lot of the same tools to manage them that we use in Agile software. You've got the cadence, you've got the whip control, you can actually do a burn-up chart of slices. I've done that and it's been useful. Not always, but sometimes. But things that are not like Agile software is these slices have a lot of interdependencies. And by that I mean you can't just implement them in whatever order you want. There's a bunch of things that have to be done before other things can be done. That's just the nature of physical objects. So you need a planning method that doesn't assume everything's up for question all the time. That's why we're using a calendar-based plan that's showing time boxes out across a schedule, because we need to see that calendar. We need to see that things are being done in the order that they need to be done in. And the slices are not individually shippable, so there's not a lot of discussion about how we would make a slice shippable, because people are just not buying a half-finished smart refrigerator. They want the whole refrigerator. So you got to have that. So to sum up here, the challenge we're facing in hardware, firmware, software integration is that the hardware and firmware and software teams are all working with different batch sizes for what are actually good reasons. And we don't want to change that dramatically. They're also using language that is different, which is partly because their batch sizes are so different and partly seems to be just historical. The result of that, though, of those two things is that you typically have communication issues, plans that aren't aligning, and that leads to wasted time, wasted effort, because people thought something was happening and it wasn't. So the slice-based integration planning helps improve the communication, which then improves the flow of work. And it's using the small batches and the common language through the slices, a language everybody understands, You're using a cadence, which gives you the structure to be able to coordinate things without driving yourself nuts. It's acknowledging that this needs to be a cross-functional question. It's not something a test group does by themselves. It's not something a development group does by themselves. And using some of the tools from Agile software development, the visual plans, the stand-up meetings, the rolling wave planning, to manage the plan in a way that's as simple, the simplest thing that could possibly work, basically. Trying the simplest thing, and then if you have to have a Gantt chart, go get a Gantt chart, but try the simpler thing first and see if it'll be good enough. So if you want to learn more about this, the paper that I wrote has at least twice as much as I just gave. It would not fit into 45 minutes. And released a book that the paper was based on about 2 chapters of a book that I published early this year, along with Catherine Radica, on using Agile principles to accelerate hardware development. And the book also talks about things that have nothing to do with integration planning, or looking at early research in hardware and how to handle that in a more agile way. So you've got a lot in there. If you're interested in trying this method, I would suggest that you, as software people, read the paper, and you and your colleagues will find the paper useful, but your hardware partners would probably find the book easier. The book is written from a hardware perspective, and the paper was written from a software perspective. So it wasn't just a cut and paste job. And there's a good bit more discussion on a lot of topics, and I'd also be happy to talk to anybody. I have a few copies of the book with me if anybody's really interested in this, but now we have questions. Yes, I will pull those out and put them on the front so you can take a look and see if it's something that interests you. So questions. Do I recognize the term NSCCA? No, I don't. So I'm sorry to a person, Angelo, I will not be able to help with that one, unless you tell me what it is.
So I didn't see in the ad would say important things.
Mm-hmm.
Risk factor, lightning broken.
So John is asking how risk-based testing would factor in the slice-based approach. That's one of the things that wouldn't fit in this 45 minutes is, yes, it can. My experience has been that when people first start using this method, just getting everything lined up is their first iteration. Their first project is just getting everything lined up. After that, they start asking, wow, now that we can line things up more easily, could we move a riskier slice to earlier so we have more time to deal with what we learned from it? And yes, that definitely a good practice, and a lot of what we think about in testing actually ends up coming into play. In what order would you like to do these slices? Is it possible to move the order? And often it is, once you have this structure to allow people to think about it and to juggle things without losing track of the work.
But is there a head of that, or is it really kind of running the decision-making process?
Different groups that I've worked with have done that differently. One of them had a program manager whose entire job appeared to be being a program manager, and that person ran the meeting and kind of made sure everybody showed up and traded their stuff. Another group I worked with had the lead of the firmware team was considered the most senior technical person, and he was managing it. Or maybe the firmware was driving things the most. Another one, I was managing it as the lead of the test team. I think it's probably better to have the development team managing than the test team, because that does kind of end up being the tail wagging the dog. You have a lot of debates with people about why they should get their stuff finished. That's not just for my convenience, really. It's because it needs to be tested. But that just seems to vary a lot in different organizations, what they find the most comfortable.
So it's not hard.
No, it's not a hard and fast rule. This is, I would say, not, this method hasn't reached maturity yet, in my opinion. So it doesn't have a do it this way like your Scrum Master and your product owner and stuff. And the hardware projects vary so much that I'm not sure it would ever get that determined or deterministic. Other questions? Yeah.
I'm just curious. Team size. This is against creating all this like convergence where you have to like work on the team to fit them into the slices, so to speak.
Yeah, the first, again, the adoption process tends to be pretty long, and the early adoption, just getting them to be able to talk to each other is the win. And then the later ones, you start talking about an integration train and having things be on time. And if you miss the train, you have to get on the next train. That's covered in the book, but it wasn't in the paper at all. So I didn't see people really getting nervous about it. The whole train concept actually frees people up a lot, because without it, they're talking about, should we release this on October 15th or October 20th? And with a train schedule running around your time boxes, you're like, it's either the beginning of this time box or the next one. There is no in between. Don't discuss it. And it's like, oh, well, now there's a whole lot of stuff I don't have to think about anymore. I only have to think about this date and this date. Cool. John.
So places I work, we have conflict was only the different teams. We have different companies. Do some of the things like we actually had to do a wire wrap for cabling so that we can continue things on and something there to, you know, at least provide. We ran into problems when things came into the outside vendor that they would rush in their slice and it was messed up. We did point the cable upside down and backwards. We had interesting arguments about fall. Did you see things like that inside of it?
I haven't worked this method on anything that had outside vendors delivering parts. Not that I remember. You do get people though delivering stuff and saying this is done, and it's like, yeah, it's still failing the test pretty badly. So maybe we need to talk about the criteria here. What are you actually considering done? Yeah, and then one of the things I did see with this is people started to have really useful discussions about smoke testing, and it's like, wow, this keeps ending up in the test group that is not working. And it's like, well, why didn't you test this with the firmware? Why didn't the firmware team test this on your own? What would you need to do that? And it's like, oh, well, we need a prototype unit. Could you use could you use this older piece of equipment that we have? And then you end up shipping it somewhere where their test team is. But people would end up having discussions and realizing, oh, I actually could run a smoke test if and what I'm asking for isn't that big. It gave them a forum to ask, to raise the question of, could I have X so I could just do this? And the test team is going, please give them that. I want them to have that. So having the forum for the discussion in a structured way seemed to really help.
Have you seen it?
Yeah, I did one once. Don't. It was really embarrassing.